Okay, everyone. Oops. No, I'm too close to the speakers. Right. I would like to introduce David Johansson, who is the Associate Principal Consultant at Synopsys. David has presented at OWASP a couple of times already. And he has presented at AppSec USA, Information Security Europe, and quite a few other conferences. And today he's going to talk to us about cookie security. So welcome, David.
Thank you. Okay, I hope you all can hear me and without too much feedback. So I'll try to stay away from the screen a bit. So this talk we'll try to run through quite quick. It's actually about a 45-minute talk that I did at AppSec in the US. So I'm going to skip one of the demos and I'm going to go through a bit quicker some of the slides. So if there's anything you find of interest, I would recommend you to Google AppSec USA and you will find a talk there and you can see the demos you will miss today. Okay, just very quickly about myself. My name is David, as mentioned, and I work for Synopsys, based here in London since about 3.5 years, nearly 4 now. And what I've been doing for the last about 10 years is work as a security consultant with delivering trainings, reviewing applications, helping developers basically to write and produce and deploy more secure code. And I faced a lot of the challenges that Jeff spoke about earlier today, so I can relate to a lot of that. What we're going to talk about today here quickly is cookie security. And you may wonder why I talk about cookie security. Isn't that it's like, okay, we all know about cookies. We had them for a long time. And we know how they work, right? So when we look at this a bit deeper, it's actually that cookie security is somewhat broken. It's not really always what we think it is. And we have a lot of security attributes and things like that. And we add to our cookies to make them secure. But what I've found is that it's not always that they work the way we would expect them to work. And they may not always secure up our cookies to the degree we would expect. And sometimes I see developers and even security experts making some false assumptions about these and how they work. And that's what I'm going to try to explain a bit about today, and just to make sure so you have the right understanding of cookies and where you might be having some weaknesses if you got some of these things wrong. So we're going to start off just with some basics regarding cookies, and then we're going to talk about some of these attributes that I mentioned, 4 of them, and then we're going to briefly talk about some of the newer and more modern protections that are actually being built into some of the browsers today. And also there's a new proposal for updating the cookie specification, which will add a few of these. So we're going to cover that. So let's start with the basics. So cookies that we use are actually based on a quite old recipe, you could say. Back in '94, it was an engineer at Netscape that created this draft for cookies. And the use case they had was to a client that kind of like created an e-commerce site, I guess probably one of the first ones out there. And they needed to store state about the users, like the shopping cart and things what they were looking at and wanted to buy. And they were afraid that it's going to cost them quite a lot on the server side to keep all this information and didn't want to store all this state information about end users. But as we know, the HTTP protocol is kind of stateless, so we need another way to actually maintain this. So that's how they came up with cookies. And just to let you know, this draft that came out, it said something like, yeah, use with caution or similar, because it was quite short. It was just about 4 pages, not very detailed. Had a high-level overview of how it was going to work, but it left some things unanswered, and people anyway started to implement this. So Netscape were the first ones, and then Internet Explorer came along and did the same. A few years later, in '97, they tried to standardize, okay, now people are actually using these cookies and how should it actually be used. So let's create a formal standard for this. So RFC 2109 came out, and no one really cared. No one really implemented it. And people kept on going with the old Netscape draft in that way, because everyone was already using that and they were so used to it. And for example, at this time in the new specification, they were trying to actually do some good things. They were trying to push more for security and for end-user privacy. For example, there was a new field, I think was called comment, where the server was supposed to tell the end user why they were setting a cookie, what was the purpose of that, so that the user could take an informed action of if they would accept that or not, or proceed using this website or disagree with that. So a little bit similar to if you're in the EU now, you know the rules. Many websites, the first time you visit them, they have to tell you that they're using cookies and why they're doing that. and you have to give your consent, so to say, by continuing using the site. And if you don't accept, you simply can't use it in many cases. So that was not really big of a hit. So in 2000, they did a new attempt. So RFC 2965 came out. Again, they were trying to make some changes and improve things. Funnily enough, they were actually creating a new header, set cookie 2, and a cookie 2 header to advertise the browser capabilities to support this. But hands up here, how many of you have seen cookie 2's set cookie 2 header or a cookie 2 request header? I don't see a single hand. Oh, there are actually 2 at the back. Yeah, been around for a while then. So it's very, very uncommon. I mean, I've tested many, many applications, and I can't remember ever seeing them being used in practice. And again, it appeared that this was something that most people and developers as well as browsers simply ignored, and they were continuing using the old standard. So again, not much happened until 2002 in terms of cookies. About this time, because of Jeff and other pioneers within application security, people suddenly became aware of that, oh, we actually have an issue here with security issues, and especially cross-site scripting was a big thing then. Unfortunately, still a big thing today. One of the things back then that people tried to do was to use cross-site scripting to steal a session cookie and send it off to the attacker side, so the attacker could then use that to impersonate the victim and take over their session. So what Microsoft did was they came up with an attribute called HttpOnly, which basically told the browser that cookies with this attribute should not be sent, should not be accessible to client-side JavaScript, for example. They should only be accessible over HTTP API. In other words, they should be sent with request to the server from the browser, but not be accessible client-side. It took a while, but then other browsers adopted this as well, and they started to implement this feature, and it's been in all the major browsers for quite some time now. So we're all familiar with this. But we still didn't have any formal specification for what should actually cookies look like and what should it be. And one of the reasons why there wasn't work being done to do this was because this HttpOnly attribute was implemented a bit differently at times, and there was no consensus regarding it really. And there were a couple of guys related to us, Johansson, for example, some of you might have heard about him, and Bill, they were approaching the standardization organization and said, hey, can we write a standard for HttpOnly for these cookies? And they came back and said, like, yeah, I wouldn't really bother with that because I don't even have a standard for cookie to begin with. So it's kind of pointless doing it for just HttpOnly. So what they then did was to initiate a work where they actually started to try to document and create a standard for cookies. And that's the one we're using today, RFC 6265. What's interesting, though, is that this is actually not a standard saying that this is how you should implement cookies, and that's how everybody did them. It's rather the opposite. They were rather specifying how do people actually implement cookies in the normal process that we use most of the time today. So we're trying to document something that was already out there and specified, rather than trying to write specification that others then would adopt and use. And that's the way it's been, and it was based mainly, again, on the cookies from '94 in the Netscape draft. This year, there's work going on to actually update this specification. It's not a major change, though. It's not trying to do something like RFC 2109 or 2965 to change completely how cookies work, but rather they're adding some new security features to it, primarily something called same site and strict secure cookies and cookie prefixes. And we're going to go over them quickly. So just to everyone be on the same page, what are cookies? Well, they're pieces of information basically that are stored on the client side by the browser. And they're typically set in an HTTP response by the server. Can of course also be set by JavaScript on the client side. And once the client has these cookies, they will include them in a request back to the server when you try to get a page on a host where a cookie was set. And these cookies, they also contain a couple of different attributes that then influence how they are handled by the client and when they are submitted to a server. So we're going to talk a bit about some of these attributes and how they relate to security, and some common myths or misconceptions, you could say, that I sometimes come across when I speak with developers and other security professionals. So the first and probably most important one that we all should hopefully know about is the secure attribute, right? So if you've ever come across a pen test report or any security training on web security, I'm bet for sure that someone has mentioned a secure attribute and pointed out you have to mark your cookies with a secure attribute. It's very, very important. And the story goes something like this. So cookies marked with a secure attribute are only ever sent over encrypted HTTPS connections, and therefore they're safe from man-in-the-middle attacks. So the point here we're trying to do is we want to prevent someone on the network between the client and server from being able to intercept or get access to this cookie. So that's why I mark it with a secure attribute. So what do you think? Is this true or false? And hands up for true? Should be all hands. Why are you setting the secure attributes otherwise? Okay, now so again, this is both true and false, depends how you look at it. So it is true in terms of confidentiality. So when you set the secure attribute on a cookie, you're telling the browser that this should only ever be sent over a secure HTTPS connection. So browser will typically honor that and they will only send this cookie on an HTTPS connection. And that means that someone between the browser and the server won't be able to read this cookie. So that's all good. Now, the problem is it doesn't provide any sort of protection in terms of the cookie's integrity. So although Mallory here in between Alice and Bob can't read this cookie, can still write or change this cookie. So that's a very important thing to keep in mind, that you have confidentiality protection, but not necessarily integrity protection. So don't make any assumptions regarding the security of the content of that cookie. For example, it can lead to XSS if you had stored some information in the cookie and you think that no one else from you or the end user could change the content of it, because an attacker in between could write a new cookie and overwrite that one with some malicious payload that would then execute when that information is included on the page. It could also lead to issues in terms of cross-site request forgery if you're using a double submit cookie pattern, for example. So for those of you who were at the OWASP London meeting, I think it was back in March, I did a presentation regarding some various ways you could defeat that. And from that, you remember that by overwriting this cookie, the attacker now controls the value that you validate against. So the attacker can also create a valid request with the right token and bypass that protection. So another thing where this could be effective is, for example, if you're not rotating or updating your session ID upon authentication. So I guess most of you have heard about session fixation, and it's basically an attack where an attacker knows the session ID and sets that for a user that then elevates the privilege from perhaps an unauthenticated user to an authenticated user in the system. And as the attacker knows this session ID value, they will now also be able to authenticate as that user towards the application. So if your application doesn't update the session ID after authentication and you're storing session ID in a cookie, this could be used to force a cookie upon the user that then authenticates and updates that session. Okay, so again, for those of you who want to see a demo of bypassing double submit cookie pattern, I suggest you go to YouTube and look up the presentation I did at AppSec in the US. We'll skip that today and move on to the next attribute, which is HttpOnly. So this is something that was intended to prevent a cookie from being accessible by JavaScript, right? So this was something that I mentioned that Microsoft introduced first and all browsers support today. And the story goes something like this, that because cookies are marked with HttpOnly attributes, they're not accessible from JavaScript, and therefore they're unaffected if you have a cross-site scripting attack on your system. So again, is this true or false? Well, just like previously, you can probably guess that it's partly true. It does protect confidentiality, but it doesn't protect against integrity. So although in JavaScript, you can't access the cookie through document.cookie, so you can't read it. And if you try to write a new cookie through JavaScript with document.cookie on something that's marked with HttpOnly, it won't actually stick. So you can write a cookie, but when you then try to read it and see what's in there, you will see that the previous cookie is still in there, and the new one you try to overwrite was not efficient. However, we can actually bypass this by overflowing the cookie jar. So all browsers, they have a limit set for how many cookies they can keep for each domain. So if an attacker is able to inject a script into your domain, they can start to overflow a cookie jar by writing a lot of cookies, like dummy cookies. And then once the original HttpOnly cookie is evicted from the cookie jar, they can now set a new cookie with a chosen value. So the integrity is not really protected in practice, although in theory it is, because you can't overwrite a cookie through documented cookie. So I have a very simple script I'm just going to show you. Switch here. So I'm not sure if it's big enough. Do you see? Yeah, hopefully you can see. So it's a very simple. Basically, it's like a small proof of concept to overwrite the cookie jar, and then to overwrite the HTTP-only cookie and then restore the previous cookies you had in there. So what I'm doing here basically is that I'm first storing the previous cookies. So I'm storing them in a temporary variable, and then I'm looping through and trying to set this new cookie that I want to overwrite the HTTP-only one. And every time I set it, I try to see then to read out, was I successful or not? If not, I iterate to set a new dummy cookie, and then I try to set it again up to max attempts. So in this case, I think I set it to 200, and most browsers will do it between 150 to 180, I think. So once I've done that, if it's been successful, then I will remove all the dummy cookies that I set and then restore the previous cookies that I stored in the variable. So let's try to see this in action. So I have Chrome here on the other demo app that I did for the CSRF bypass. So here we can see we have a connect SID, right? So this one is marked with the secure and the HTTP-only attributes. So if I now try to simulate that we had a cross-scripting attack, so it would run within this domain. So we can just check document domain, for example. So we see we're on this server, right? So now we simulate that we have a cross-scripting attack. So if I now try to read this cookie here, we see that we don't really get anything, right? So HTTP only works, it protects me from being able to access the value of the cookie. Now let's try to set a cookie. So if you say, type something here, that's document cookie, and yeah, had something in that last year. So let's set it to like, sorry. Let's check if it was the right name. Connect.sid. Connect.sid. Okay, so let's try to overwrite this cookie now. And if we now try to read it again, we see it's still empty. And if you look here and update, there's no new cookie, right? So we tried here to overwrite the HTTP-only cookie, but it was not successful. And that's due to the browser blocking us from accessing this cookie, reading or writing to it through the JavaScript. So now, just to see that we can set another cookie, let's set a different name. So if I write this one, we see that it's actually there now. So we're able to set this cookie with a different name. And if you look at the application here, we see we have a different cookie, okay? So we have these cookies now. So we were able to set normal cookies, but we're not able to overwrite HTTP-only cookies. So let's go back to our script here now, and let me just see if I manage to copy everything, and then just drop that down here into the console. And in theory now, hopefully, what it should do is should actually store these previous cookies that I had, and then it should try to evict the HTTP-only cookie and then overwrite the connect SID with a new value. So if you run this, we see that before it was only able to access this dummy cookie. Sorry, down here. And then we see after 179 attempts, it was able to overwrite the cookie and evict the previous one. And then we restore the jar. And this is because we had one cookie or two cookies before, and Chrome, I think it's 180 cookies you can store per domain. If you go back now to this one, we see that this cookie connect SID that was marked with HTTP only and secure before is now overwritten from our JavaScript. And the previous cookies that was there, I've restored that because I was saving it while I was flushing the cookie jar. So by using this technique of like overwriting and evicting cookies, you can actually tamper with HTTP-only cookies. Again, I don't think the risk is nearly as bad as if you could read it in most cases, but there may be instances where overwriting content on an HTTP-only marked cookie from a cross-scripting attack can be valuable. Okay. So the next one I want to discuss is the path attribute. So this is something that we sometimes see in some recommendations. I think even in some of the OWASP testing guidance I've seen. When we talk about sorry, that was the next one, domain, talk about that the path attribute is used to scope a cookie to a specific application. So we should try to, if we have two different applications, for example, on the same domain, then we could isolate them from each other by using the path attribute. So that if there's a vulnerability in one, for example, across scripting, that would not be able to read the cookie of the other application. So it may sound good in theory, but if you think about this in practice, it's not really something that works. And the reason for that is that cookies are quite different from other things in the browser. So normally we have the same region policy that will prevent different domains and applications from interacting with each other through your browser. But the cookie scope is somewhat different. So if you look at the cookie scope, it's defined by the path and by the host or the domain that is set for. But if you look at the same region policy, it's using the host and the port and protocol. So these are somewhat similar, but they don't fully overlap. There are some differences here. And that becomes important if you have two different apps. For example, here we have app 1 and app 2, and let's say we want to try to isolate them from each other in terms of security. As I hope you know, this is not possible to do just by having a different folder where you host them on if you're on the same server. Because even for cookies, if we can distinguish them in terms of the path that we set, they are not actually isolated. Because in terms of cookie scope, they are. So if I'm on app 1, I wouldn't be able to read a cookie scope to app 2 and vice versa. But through the client, because of the same region policy, they look the same. So with client-side script, you could actually make a reference to the other app on the same host, and you could grab the cookie from there. Okay, the last one of these attributes I want to discuss is the domain attribute. So sometimes we see recommendations like this, that you should set this domain attribute to be the origin host that you want to limit the scope of this cookie to. And for example, if you have your app on app.mysite.com, then it should be set to domain equals app.mysite.com. So is this true or false? Good recommendation or not? Well, it's certainly better to do this than to scope it to the parent domain. You've limited the scope, but it's not really always doing what you think. So you may think that you've now reduced the scope to only that host, but in fact, it's visible to that host and all its subdomains. So the risk here, of course, with subdomains is lower than if it was scoped to a parent domain, but it's still a relevant risk. For example, you may have different system, for example, may distinguish between dev, test, and prod by having different subdomains under your main domain. And anything you now scope to your main domain or to a production domain could be accessible perhaps in your test or dev environment. And I know for some companies, having production data accessible in a test environment is a big no-no. So in these cases, you need to be a bit careful with how you scope your cookies. And the best thing is actually to not specify the domain attribute at all. Because if you don't specify the domain attribute, it will be a host-only cookie. And in most browsers, except IE, unfortunately, it will only be sent to that host which set the cookie. Okay, another thing I want to talk about very briefly is cookie lifetime. So here's a quote from Wikipedia. It says that a session cookie, also known as an in-memory cookie or transient cookie, exists only in temporary memory while the user navigates the website. So is this really true or false? Well, I wouldn't blame you if you believe this, because this is something I believed for quite a long time until I realized that it's not always the case, actually. So it is true that it only lives is accessible and available as long as the session is alive. And the danger here is believing that the session is the same thing as your browser is open. Because of how browsers work, they can decide when the session ends, and it's not necessarily when you close the browser. And non-persistent cookies can actually survive a browser restart and perhaps even a computer restart. Because, for example, if the browser crashes or something else, you might have noticed that when you restart it again, you get this, do you want to restore session kind of question. And if you do that, it will retain all those session cookies that you had. And Mozilla actually explicitly warns about this, that if you have something sensitive in your cookies and you want that to be, you need to make sure that you eradicate that and expire the information and not rely on the browser to do that when you close it. So you shouldn't store anything sensitive that shouldn't be around for a long time in a cookie, because that could be persisted and potentially be accessible to someone even after browser restart. Okay, so that was some of the content regarding how cookies work today and how to look at some of the potential pitfalls that you could fall for. So what is happening in terms of cookie security, and can we make this better? Well, there are actually some work going on right now in 2017 to make this better, and this is an update to the RFC. So the first thing that you're trying to bake into this is what's called strict secure cookies. And remember before how I said that a secure cookie marked with secure could be overwritten through a non-secure origin through a man-in-the-middle attack. So this is what this is trying to stop. So what it does is that enforces that a cookie marked with secure can only be set from a secure endpoint, in other words, of HTTPS, and it can not be overwritten from a non-HTTPS origin. So that means that it wouldn't be possible to overwrite an existing secure cookie through man-in-the-middle attack unless you would be able to get break the TLS connection, so to say. However, it's not 100% protection against setting malicious secure cookies, because attackers still has a window of opportunity to preempt these cookies with their own. And for example, this is relevant if you look at the CSRF protection, where you have stored a CSRF token in a cookie, because some frameworks then may rely on checking on if they get this cookie already, and if they get such a cookie, they won't set a new one. So if an attacker can first plant such a cookie, they can later exploit that to use that knowledge and bypass CSRF protections. The next thing in this new update is something called cookie prefixes. And the problem it's trying to solve here is that when we send the cookie from the client to the server has no way of telling whether that was a secure cookie or whether it was marked with HttpOnly or any other attributes. So the only thing that gets sent to the server is the name of the cookie and its value. So the server doesn't really know where this comes from, and it doesn't tell anything about the security properties of the cookie. So the solution here would try to be backwards compatible by smuggling some of this information in the name of the cookie. And it's obviously not a beautiful solution, and even the first draft of that had a note about that. It's an ugly solution, but it's the best thing we can do without breaking things or introducing new attributes. So the two of these, the first one is called secure, and the other one is called host. And as security experts, we have not really done a good job of helping developers to get things right. And it was said before, like, we shouldn't blame the developers, because you would have thought that the secure one is not the most secure. So you would think that if you want to secure, you should use that one. So the host one is actually more secure because it's more strict. The difference here is that the secure prefix enforces the cookie to be set over a secure channel and to have the secure attribute set. So the server can now know by looking at the name that it's a secure cookie. The host one goes a step further by enforcing that this cookie can only ever be scoped to the specific host that set it. So you can't set a cookie marked with a host attribute and scope it to the parent domain, for example, to widen the scope of the cookie. And you also can't specify different path than the root path of the application. The last one of these is the same site attributes. And the problem here we have is that cookies are automatically sent with the browser whenever request we make to the application for which a cookie was set. And as you know, this can be abused by attackers in various different attacks, such as CSRF, cross-site script includes, and other types of attacks where we rely on the fact that the browser automatically submits this information. So the solution they came up with here in the same site attribute is basically to apply this attribute to cookies to tell the browser that this one should not always be sent. They should only be sent when a request was initiated by the same site, by the same origin. So that is trying to prevent these cross-site request forwarder attacks where another region could initiate a request to your site and thereby fool your browser to include a request and make it look like you initiated it, when in fact it was just another site you happen to browse by. And the two different modes of this, I'm not going to go into details. I recommend you read up on it if you want more information on that. But it's basically to prevent these cross-origin requests. from attaching these cookies. So it's something you would put on your, typically your session cookie. Okay, so that was a quick run through of this. So let me just briefly end with some key takeaways here. So the first one I want you to be aware of, if not already, is that cookies are still largely based on a draft from 1994. So it's a very old recipe we have, and it has a lot of security weaknesses and flaws that we need to be aware of. And knowing this hopefully helps you to not build your applications with false assumptions regarding cookies. Especially I want to point out that the integrity protection of cookies is very, very weak, and you should never rely on the content of a cookie not having been modified by a malicious entity. Be very careful with that. So don't trust your cookies blindly. And the last thing I want to point out here is that application and framework developers should really start to take advantage of these new improvements. So some of these are already supported in browsers. For example, Firefox and Chrome both support strict secure cookies and cookie prefixes. And same site is also starting to get support in browsers as well. So there's a lot of good things happening, and I hope that within the next year, this will be standard across all modern browsers. And this is something that we should start to implement in our applications, in our frameworks, for example, default to these host prefixes, and make sure that we tighten up the security around the cookies. For now, though, be aware of that not all browsers work the same, and you should not rely solely on these mitigations yet. So, for example, I wouldn't recommend anyone to just add the same site to your session cookie and then don't care about cross-request forgery, because you might still have users that would be vulnerable. Okay, looking at all these new attributes and things we can use for cookies, is there something like a ultimate cookie that would make us the most secure one? Well, we don't have anything that protects against everything, but this is probably as secure as it gets right now. So what we can see here is that we first off use the host attribute. As I said, you will now restrict this cookie to a specific host, so it's not shared across a parent domain, for example. And also that implies that you need to set the path to the root, and also set the secure flag, so it can only be set over a secure channel. The next one is HttpOnly, which means that this cookie can't be read by any JavaScript. Unfortunately, as we saw before in the demo, we can still overwrite them by evicting cookies, but a JavaScript can't read the content at least, so we have a confidentiality protection from cross-scripting. And the last one is we use the same site with a strict mode, which enforces the browser not to send this cookie unless a request was initiated by the same region that we are making the request to. Okay, that was it. Any questions?
Okay, let's thank David for his talk. Right. As usual, Bristol guys have priority. So guys in Bristol, do you have questions for David, please?
So when you're going through and overflowing the cookie jar, could an argument be made that any cookies which are set via JavaScript do not replace the ones which have already been set by HttpOnly?
Yeah, definitely. So actually, that's what they're doing for the secure ones, right? So from an unsecure origin, you can't overwrite the secure cookies, because you could try to do the same to evict a secure cookie, but specification prevents that if the browser supports strict secure cookies or the new HTTP update to the cookie specification. In terms of JavaScript access and overwriting HttpOnly cookies, there is no such thing yet. It's funny that you mentioned, because I actually today filed an issue on the new draft specification, pointing out that they should add that. So hopefully they will pick it up and do something about it, because I can't see any good use case for when a JavaScript should be allowed to evict HttpOnly cookie.
Yeah, great. Thanks. Any questions, guys? I also put the slider. Don't forget to use the app to ask your questions, because the speakers will answer them after the event as well. More questions from Bristol, please.
Everyone looks happy, so questions in London, I guess.
Before we start questions in London, I'm going to use this cool microphone. which I can throw, right? So if you raise your hand, I'll just throw the microphone. There's a little cross here, and you can speak into it, okay? I just need to switch it on. Hello, hello. Okay, questions?
What's your head?
Where is it? All right. So actually, I had a question on the integrity, right?
Yeah.
Because you kind of meant that when you use a secure, right, you can compromise the integrity. So that one is a bit confused, right? Because I was under the impression that Excel provides also integrity. So you're not meaning that you can actually put values in the man-in-the-middle, correct?
You can do that. So it depends which browser you're using now, because as I mentioned at the end, that Firefox and Chrome this year, they started to implement the strict secure cookie, and that is what prevents you from overwriting a secure cookie from a non-secure origin. But in other browsers, not supporting that.
So you're saying that you can write it on HTTP, right?
Yeah.
So when you are in HTTP, you can overwrite the HTTPS one. Is that what I mean?
Yes.
But not in the middle. You cannot change this.
No, I don't mean that you man in the middle HTTPS connection.
Yeah,
but
okay,
what I mean is that what you can do is that for any website, any browser basically, if a user is browsing any page on HTTP, what an attacker can do, if you're a man in the middle on the network layer, you can intercept that request, and in the response from that HTTP request, you can inject some content that would generate a new HTTP request to a target site that you want to overwrite a cookie for. So even if that target site doesn't listen to HTTP at all, the attacker will still be in between, right, when the browser generates that request. And the attacker could respond with something and then set a set cookie header in that would then overwrite the secure cookie.
But if you have the HTTPS header, then that is not possible.
Yes, so that's a protection against that. Yeah.
Or if you have the web application firewall too.
So
because general integrity is protected by the web application firewall.
Yeah, quick question on WAF, whether that will protect?
Not sure it would. It doesn't protect you from being able to overwrite it as an attacker. It depends if the browser, if on the other end, if you compare it with what was set, then maybe you can detect that a change has taken place and you can do something about it. But the overwriting it as such doesn't. Yeah, I mean you can detect. Yeah, if you check if it's changed, you could check that. Yeah.
Oh, you mean if the WAF is working as a reverse proxy and it will act as a filter? Okay.
All WAF have to be a proxy in the middle, and so it's mandatory for that to inspect the request. It's the reason why the first statement about the fact that somebody in the middle get prevented, no, because an attacker on local could also create a host entry on the host.
I thought, regardless of SSL, I thought you were suggesting that a JavaScript attack could also compromise the integrity of the cookies. Wouldn't that require an XSS attack? Unless you were trying to do a self-cookie attack, you'd have to have an XSS in order to execute that, though, right?
Yeah, so that was targeting the HTTP-only attribute, right? So the context was HTTP-only. What does that protect against? So we all know that it protects a cookie from access through JavaScript. That's the purpose of it. But what not everyone is aware of this, that you can still overwrite such a cookie from JavaScript. So if you have a cross-scripting attack, you're not safe in terms of integrity of that cookie, but you're safe in terms of the confidentiality.
Yeah, exactly.
Yeah.
Yep.
Any more questions? Jeff has the microphone. No more questions? Right. Okay. If there are no more questions, I'm going to finish with the last finishing things. So can we please thank our presenters, Jeff Williams and David Johansson? Can we please thank beer and pizza and Kevin Fielder, the CISO, sitting on the table over there. Thanks, Kevin. Okay. So we're going to go to this pub now. All right. Let me, can you see the pub? Where's the pub? I think I'm sharing the wrong page. 1 second. Let me share the pub information. Pub. Right. Okay. Can you all see the place where we are going now? This is the place. Okay, so we're going to continue until 11 p.m. the pub closing time in here, the Viaduct Tavern. You exit this building, you turn right, you will see it. So next meeting is on 25th of January. Please follow us on Twitter, Facebook, and subscribe to mailing lists. Those of you who are members, I will give you the stickers. There was a question, so all the presentations will be published on the OWASP website in the next couple of days, and hopefully the live stream will be on YouTube. Thank you very much, guys. Thank you.
London, that's it.
Okay, Bristol, we need to end the stream now, right?
Yeah. I said good night.
You need to pause stop recording, right?
Yes, that's what you need to do.